Innovation and Sustainability at Keller, top 20 under 40 from Ottawa, Ontario, Canada. Dr. Kimberly's responsibilities include driving initiatives, innovation initiatives to advance Keller's carbon reduction targets, as well as developing and advancing and advising on Keller's internal and external social initiatives. Dr. Kimberly has a Bachelor of Science in Civil Engineering from the University of Arizona. Yeah, go Wildcats, I have to say this. And she has a Master's of Science in Geotechnical and Geo-Environmental Engineering from the University of Texas in Austin, and a PhD in Civil Engineering from the Arizona State University. Dr. Kimberly's topic is going to be on advancing sustainability in the geotechnical industry. Dr. Kimberly, the floor is yours.
Thank you. Thank you so much for having me. This is a really interesting group to get to present to that I wouldn't normally get to talk to. So can you guys see my screen okay? Yeah, okay. Yeah, so my background
We can't see your screen, sorry. We can only see your image, like your.
Okay. Oops. Oh man.
I have to say, it's very nice to see you.
Let's try this again. There. There.
I just made you a presenter, and that should probably help. Yep.
Oh,
there.
I thought I was.
There you go. Thanks.
Got it. Okay, did that work?
Yes.
That's it.
Okay.
Okay.
Great. Yeah, so my background is civil engineering and more specifically geotechnical engineering. Kind of came up in the oil and gas industry and then pivoted more into sustainability, which we'll go into detail here. And this is probably a little more ephemeral than the typical topics you do in the codes, but hopefully something to think about for you all in what you're working on. I'll just cover sustainability and sustainable development, what I mean when I say these words, what we're talking about, go through some rating systems you may be familiar with, and then talk about how we can pivot that into sustainable companies and organizations, and then what we can really do when it comes to environmental sustainability and social sustainability. So hopefully many of you have heard of taking a sustainable approach to development, and we typically hear about it and think about it as the triple bottom line. So we have the balance of social equity, environmental protection, and economic viability. And we're looking for that sweet spot where we can continue to develop, but do it in a sustainable way to protect our planet and our people for the future. When I think in the building industry, when we think about sustainability, we often think of the rating systems that many of us know. Probably the most famous and common one is LEED. I think it might be called Green Star in Australia and New Zealand, but this is, you know, spread out across the world in BREEAM as well in the UK. And I think LEED has done a great job really promoting the ideas of sustainability. But there's also new up and coming ones like Living Futures, which we're seeing a bit of, you may hear of. And then in North America, particularly the United States, we have Envision that is kind of like the lead for infrastructure. So if you're more on the infrastructure side, then you would hear about that. So these are the rating systems. There are many of them, but ones that many of us have heard of. But I just want to like step through them so we can see, you know, what do they actually look like? So here's Envision. You have all these different areas that you can impact, and a project tries to impact as many as possible. And usually there's like a good, better, best type of system. So just to jump in from a geotechnical perspective, how this looks is quality of life, as an example, preserving historic and cultural resources. This is something as geotechnical engineers we do, and structural engineers as well, to go in and rehabilitate a historic or cultural resource to maintain it and allow it to continue use. There's also things like preserving views and local character. I think a big piece of this is putting things like parking garages underground so we don't have to ruin the views and waste space with parking. Then there's a section called resource allocation. This can, there's many different areas, but things that I think we can directly impact are reducing that embodied energy. As engineers, you know, making sure the materials we use are low carbon, and I'll talk a lot more about this. Supporting sustainable procurement practices. This is best practices to support our local communities, minority-owned businesses, women-owned businesses. Reducing excavated materials. As a geotechnical engineer, civil engineer, this is a big one. You know, if you're cutting here, try to use that material as fill on the same site, so we're not trucking it off and taking it to the landfill. And then energy consumption and renewable energy. What can we do to improve that on the buildings and the projects that we have? And then there's leadership, plan for long-term monitoring and maintenance. This is one that I think engineers are good at. Geotechnical engineers even have a method for this, the observational approach when, for example, we build an earthen dam, putting in piezometers and extensometers to make sure that we're monitoring the performance and we recognize when there's issues and get ahead of that and make improvements if needed. And also extending useful life. Again, as engineers, this is critical, whether we're, you know, it's an older building and rehabilitating it, or designing a building so that it can eventually have another story put on it. Just thoughtful things we could do in advance. Then in the natural world, we have things like avoid adverse geology. As a geotechnical engineer, this is a big one. Many of us know that work in earthquake-prone areas that we certainly don't want to put a building on a fault line. Avoiding unsuitable development on steep slopes. It seems like a given, but we see this actually does happen, right, around the world where people are building on slopes that are unstable, particularly after rain events when that happens. Restoring disturbed soils is something we can do, particularly with remediation techniques on the environmental engineering side. That kind of mixes with my company on the geotechnical side, allowing us to use land that once wasn't really appropriate for use because of contamination that had previously happened. And then lastly, we have climate. So in this area, assessing climate threat. I know this is a difficult one for codes as climate change occurs and we're trying to understand adaptability and resilience, and that the climate we design for from the past 100 or even 30 years is not the climate that we're seeing going forward, and also preparing for long-term adaptability because of all the unknowns in the future. So this is kind of what assessment rating system is and how it looks, and you can see these direct ways that as engineers we can impact the sustainability of a project. Now, my problem with these rating systems is that they aren't used very often. And so when I give this talk to groups of hundreds of people, I'll ask, you know, how many of you in the past year have worked on a LEED or Envision certified project? And I would be lucky to have half of them say yes. And then if I ask, how many of you were actually key to determining that a project would go through LEED or Envision? In geotechnical engineering, it turns out to be very few. So this is just not something a lot of engineers are regularly working on. And I don't want people to think that because we're not working on a LEED or Envision certified project, that project can't be sustainable, because we have a lot of issues that are coming from the construction and building world and infrastructure world. And we're not going to be able to fix this and do better if we're waiting for projects that are LEED certified or Envision certified. We have to just do better all the time. So how do we do it? So I like to use the United Nations Sustainable Development Goals as a framework for companies and organizations. So instead of saying, this project will do this, we can now say, as a company, we're going to do this. And we can take these SDGs and use them as a framework, which many people do. They also align with a lot of sustainability reporting standards. We like these UN SDGs because they're universal. Every country that signed on to the United Nations has signed on to these UN SDGs. And also they're holistic. So they're not just covering the environment, they're also covering social and governance as well. They can be overwhelming. So they are covering everything. There's 17 of them. However, a company doesn't have to choose all 17 to address right at the start. You can say, hey, you know what? We need to really focus in these areas. And a lot of companies start with number 3, good health and well-being, because for us in construction, safety falls under that. And that's something that we're good at focusing on. And then gender equality, we know we need to increase diversity, responsible consumption and production. That's really important about resource use, and then climate action, of course. So you can break this down and make it more specific to your company instead of trying to bite everything off at once. Once you decide what to do, then a company can make commitments and targets and say, hey, you know, we are gonna reduce our waste, or we're gonna use more recycled content, and this is what we want to do by this year. And we can set that and share it with our employees. And then once we do that, we can start reporting externally and get a rating and assessment and be transparent to our stakeholders. So when we take this company-centered approach, I think it's much better than the project-centered approach, because now we can say, as a company, we are going to do this. We are going to set targets and we are going to do better. And that's going to be on every project and everything we do. So where to start? It can be overwhelming, like I said, and just for the environment, you can see how many UN SDGs are covered. So how do we decide what we're going to do? Well, I propose that you start with climate action, and here's why. So I think this will be interesting for you all from a code's perspective, because a changing climate really affects what we have already built. So we have a representative here from the Pacific Northwest in the United States, but we had a few years ago, a heat dome over the Pacific Northwest in North America, so Washington and Oregon. And it was so hot, it actually was beyond what people had designed for and kind of melted the infrastructure. Things were really damaged. We had just not designed for that type of heat. It didn't think it could be sustained at that level in the Pacific Northwest. We also have things like sea level rise that many of us have heard of, but we also often forget that if the sea levels are rising, we would have associated rise of groundwater flooding right next to that sea level and inland further. And we have a lot of things buried underground, like pipelines and tanks that will now become buoyant and have more buoyant forces acting on them. So that's something we need to think about as climate change happens, but also thinking about the things that have already been put into the ground. And then also we have really interesting research coming out of the University of Chicago by our Northwestern University, Alessandro Roccaloria, talking about how we're also experiencing underground climate change. So this has been well documented by Professor Roccaloria in the Chicago area, showing how the ground is drying out from basically the urban heat island effect, and buildings are settling at an increased rate because of this. So here we have things, you know, we're often thinking of climate change in the future, but we do have to look back and think about the things we've already built and hopefully help try to stop this. Climate change also affects how we work. So many people remember 2 years ago, the summer, the Canadian wildfires that came, brought smoke down into the United States and made it really difficult for workers working outside in the construction industry. Obviously, a lot of what we do is outside. But it also happened a couple of years before that, where there were wildfires on the west coast of North America, and it brought poor air quality to the east coast. So when we think about things like wildfires, that's not a isolated event in the outback of Australia or in the Western United States. That smoke can actually impact how we're going to build, how we're going to get the work done in other places that are unexpected. Also, worker injuries tied to heat are vastly undercounted. We have to get these buildings built, and that's what we're trying to do, and the infrastructure built. But our workers are starting to suffer because of the increased temperatures during the day. But even further, particularly in climates that are more temperate and weren't expecting such heat, the nighttime temperatures are rising. So our workers are going to work, getting exhausted, going home. They may not have air conditioning, and now their body's not recovering at night. So just leading to even worse heat-related illnesses. I also want to think about what it means to things like our supply chain. So we had this hurricane come through on the U.S. Gulf Coast, slamming the Gulf Coast region, particularly Louisiana, hitting them very hard. And this had a direct impact on Keller in a couple weird ways. So one, we were working in the Gulf Coast and our projects were shut down for upwards of 30 days because of the flooding. But also there are a lot of chemical plants along the Gulf Coast, and we use things like PVC pipes in our drilled shaft foundations for specific testing that we have to do, like gamma ray logging. And we couldn't get those PVC pipes because these factories were shut down. So thinking about how climate change is going to affect how we work, it's not just physically how we're going to do the work, but also these supply chains. And there's great research out of MIT saying that climate change will disrupt supply chains worse than COVID. And we could say during COVID, it was actually both things, but that the best way to limit the impact on the supply chains is for companies to be proactive in reducing their own carbon footprint. And lastly, I want to say that climate affects the types of projects proposed for the future and how we're going to build them. So we have lots of money coming out from different state governments, federal governments supporting renewable projects, resiliency projects. These are very specific types of funding, encouraging how we're going to build. And I heard you talk about home building. There's also regulations about home building and sustainability as well coming out depending on the jurisdiction. And also you have things like New York City saying we're not going to allow supply of natural gas and oil in new buildings being built. So how are they going to do heating? And we'll talk a little bit about that later. But I really want us to think about how just three materials, concrete, steel, and aluminum, or cement, steel, and aluminum, are responsible for 23% of total global emissions. So particularly when you're looking at codes and you're looking at what's happening with new regulations like the Corporate Sustainability Reporting Directive coming out of the European Union, are we going to be able to continue to build in the same way we were in the past when our own work is causing so many issues with climate change? We're such a huge contributor. And I think the answer is no. The materials as it stands today are just not going to be the materials of the future, and there will be regulations around that as well. So these are the reasons why we need to change. What does it mean? How do we do it? Well, when we approach like how we can change what we're doing because of climate change, we kind of look at it in two ways. And the first way is adaptation. So I think we see this in a lot of codes. You know, how can we enhance resiliency? And we typically see that through armoring and strengthening, controlled failure, relocation. In the geotechnical world, we think about this for earthquakes and liquefaction mitigation, where if we have a building that's going to be built on liquefiable soil, we can improve the soil so that the building doesn't fall down. We can improve it enough so that there's egress in the case of an earthquake, or we could just not build there. And for those of you, I think there's at least one person from New Zealand, that's what happened after the Christchurch earthquake, where basically there's huge swaths of land where the government said, we're just not going to build here anymore because of the liquefaction. So this is adaptation, all these different approaches. What we're trying to do with adaptation is prevent the worst case damage scenario. The other way to look at it is mitigation, and that's how we build. So here is where we're getting to addressing the cause. What I'm talking about when I'm saying our building materials of the future are going to be different, because we need to think about net zero and reducing our own impacts as an industry and as companies. So here we're considering externalities when it comes to decarbonization. It's not just the materials. I'll harp on that and you'll see why in a little bit, but also, you know, how much fuel are we using to build something? What's the travel associated with this and what's the carbon impact? What kind of electricity and fuel are we using on site? And are we designing for the future for the building during construction? So when we mitigate, we want to prevent the worst case climate scenario. So what I like to say, and I hope we can all get on board with, is when we're adapting, we don't want to do that in a way that makes the situation worse. If we do need to adapt, we want to mitigate at the same time using those low carbon solutions to prepare for the future. I'm going to mostly talk about mitigation today. I'm sure you guys hear a lot about adaptation in the terms of codes and adding resiliency, but mitigation, addressing the root cause, is something I think we can have a big impact on, and I'll show you how. I also will touch on maybe how we could be net positive. So when it comes to climate change, reducing our carbon, how do we know what we're doing? It usually begins with a life cycle assessment, and we often think of this as like a materials, but here you can see for a car, goes all the way back to raw material extraction to build that car, the processing of that material, the manufacturing of the car going through its use phase. Don't forget the impacts of the fuel that it's used. So that's something that's being input into the car use, right? It has to be accounted for and allocated for. Then the end of life and recycling. A life cycle assessment is a wonderful tool. It covers so many things beyond carbon. So not just greenhouse gas emissions, also air pollution or smog, water pollution, resource use. You can see the list there. So it's very thorough about the environmental impacts of a product through its entire life. You might see this type of thing coming up in the building industry with environmental product declarations. Environmental product declarations are coming from the suppliers, and they're telling you the life cycle assessment from cradle, so resource extraction, to gate, so before that product, once it's finished, before it comes to your construction site, what are the environmental impacts of that product? And they're really, really great. And you can see here, just for climate, it'll tell you, for example, in concrete, 1 cubic meter of concrete, in this case, with this next design, has 426 kilograms of CO2 per cubic meter. So these life cycle assessments are wonderful. They have so much information. For climate, a great place to start is just to look for the CO2 emission. And there's other ways to get that information as well if you don't have an environmental product declaration. So for the geotechnical industry, we have an industry-specific and industry-developed carbon calculator that we use. It's free if you just want to take a look. It's at geotechnicalcarboncalculator.com. But there's a lot of these you'll see coming out of the the ASCE in the States, the American Society of Civil Engineers. The Structural Engineering Group has the SE 2050, and they have their own carbon calculator. The Associated General Contractors of America also have their own carbon calculator. So there's lots happening because it can be hard to do this on your own. And carbon is so important, and hopefully I made the case. So these are just really focused tools to help us understand the body carbon of our projects. So we call them cradle to gate because, like I said, they usually go to raw materials. In the case of these construction tools, are going to go all the way through actual construction. So bringing those materials to site and the fuel we use on site and then handing that over to the owner. And they report on scope 1, 2, and 3 emissions. Scope 1, 2, and 3 are how the Greenhouse Gas Protocol defines carbon scopes for companies. So you might hear about it. Scope 1 are the emissions from the fuel we use. Scope 2 are the emissions from the electricity we use. And then scope 3 are emissions from everything else that comes onto a site and how it gets there. So these carbon calculators are great because now we can really start to measure it in an easy way. You can embed things like an environmental product declaration, like I showed you, if you know what materials you're using, but also they have the general emissions factors for those materials, the generally accepted emissions factors coming from databases like EcoInvent or EC3, if you've heard of those. What I like about our industry-specific one for geotechnical engineering is it has these simplified ratios, so it can be confusing for designers, as an example, or it can be hard for them to know how much fuel would be used on a construction site for a specific type of foundation type. So this calculator can help them use some ratios from case studies, so they don't have to know all the information. They mostly have to know materials. But also these carbon calculators are great because they'll highlight what you should focus on. So in my industry, if you're doing a drilled shaft solution, you'll see that materials are going to be 95% of the embodied carbon of that solution. So if you're working on something like that, focus there. If you're doing something like a ground improvement solution with stone columns, then the stone itself has less material impacts, and you could maybe start focusing on fuel. So this is how we use them. I think they're just really helpful because most of the tools that are available online right now for the civil and construction industry are pretty simple to use, and there's lots of videos on how to do it. Next, I want to say when we're going into carbon reduction mode on a project, it's really good to use the carbon hierarchy. And the first step of the carbon hierarchy is eliminate. So eliminate emissions completely. This could be a virtual call instead of traveling. Eliminating in our industry, we think of eliminating really intensive materials like concrete, steel, and cement. Once you decide, okay, I can't eliminate, this project's going to be built, in our case, the foundation material, existing soil is not great, we're going to have to do something, then we can reduce. So what do we need to do to have the smartest design possible? We don't want to waste, right? Can we use the less number of foundation elements? Can we shorten those foundation elements? What can we do to make sure we have the smartest design? Do we need to do more testing so we can reduce risk and reduce the number of things we need on site? That's the next step. Then, if we know we have to have foundations, if we know we have the smartest design, then we get into substitute. And that's where you hear about things like low carbon concrete. So why substitute is further down the line of the carbon hierarchy is because these are still resources. even though slag, for example, is a byproduct or waste product of the steel manufacturing industry, doesn't mean we should waste it, right? We want to take this hierarchy very seriously and also have responsible use of materials. Then at the end, we know we have to have it. It's the smartest design possible. We've substituted to low carbon alternatives. Then we can compensate through things like high quality carbon offset. So we want to be sure to follow that hierarchy. So here's just some quick examples on what this looks like in practice. This is a project we did in Singapore for Neste. It was an important owner because they're building or they're producing sustainable aviation fuel, renewable diesel. So we knew they would care about having a low carbon solution. The traditional solution in this part of the world in Singapore is, they call them driven spun piles, so concrete piles, which are energy intensive. And what our engineers did is went through and said, okay, do we need that concrete? Do we need steel? What can we do instead? And they came up with a really clever alternative solution using compaction and stone to solve the problem. And they found that it was also faster and cheaper. So when I'm talking about lower carbon solution, what do I mean? In this case, it was cutting over 3,000 tons of carbon emissions just for the foundation. And I want to just break it down in scope 1, 2, and 3, because you'll hear this in the company-centered kind of approach. We didn't have any scope 2 emissions because we didn't use electricity. But if you had just looked at fuel use as an example, the vibro techniques use more fuel than the concrete technique. So we really have to look at the whole picture and say, okay, what materials are we using? What else is happening on site? And you'll see here in the scope 3, that's where the materials impact is having, and it's huge. It's really, really big, and we can't ignore that. So when we cut over 3,000 tons of carbon emissions, what does that mean? It's the same amount of emissions from driving a car 350 times around the equator. And also, it's the same amount of emissions that would be sequestered by over 4,000 acres of forest in 1 year. So it takes a lot to mitigate that level of emissions. And this is one construction project. Next, I'll show you an example of reduce. So this is in Florida, where we have a traditional, like a kind of standard high-rise residential building built on sand underlain by limestone. So these would be drilled shafts, which is a concrete solution. Our team recognized that the quantity of shafts was fixed because they were supporting the columns, but they could drill deeper into more competent rock and then increase the strength of the concrete and reduce the diameter. So to just have better compatibility between the concrete and the rock. So they were able to reduce the diameter by 35% by going 10% deeper. So they knew they had a reduction in the total amount of concrete. But if you know about concrete mix design, which I'm sure many of you do, as you increase the strength, you increase the amount of cement. And cement is the part of concrete that has the highest carbon contribution. So they wanted to know, does that actually reduce the carbon? And we did the calculation, and sure enough, it did. It was a 10% carbon savings and schedule and cost savings as well. But I wanted to push them further. They'd done that really smart design, but what happens now if we substitute? So instead of using type 1-2, what if we use type 1L cement? That's the limestone cement, 13% limestone. They could reduce another 100 tons. What if they were able to get 25% slag to replace the ordinary Portland cement? In that case, they could reduce another 300 tons, or going all the way to 75% slag blend. Now they're over 1,000 tons cut from the original. Again, that's over 1,000 tons of carbon is the same amount sequestered by 18,000 tree seedlings grown for 10 years. So recognize the impact to try to mitigate that. And also, my company does about 7,000 projects per year. So if on average, we could cut as a company 1,000 tons on each project, it starts to add up and make a really big difference. All right, other areas to reduce carbon in geotechnical engineering are things like site selection, like we talked about, avoiding that adverse geology, making sure you're building the right building on the right land, doing more site characterization and investigation. Having a better design where we're carbon focused from the outset can really make a difference. Increasing load testing, which also helps with risk as well. But a lot of codes, when we do load tests on foundation elements, now we can use a lower factor of safety because the risk is reduced. And also influencing the industry. So we want to be able to use these alternative products and solutions where it's possible And a lot of that is going to be through performance-based design versus prescriptive design. Okay, so I do want to do a little bit of forward thinking here. I'm going to if we're okay on time. Just thinking about energy and carbon sequestration from a geotechnical perspective, kind of where we could go from here and how we could do more. So one thing for energy, I think that's very exciting for us is using the ground for heating and cooling. And by us, I mean geotechnical engineers, but also anyone working in the building industry. So what does this mean? We want to be able to use ground source heat pumps to reduce the amount of energy that's required for a building. And we can do this by putting these loops into the ground, these geothermal loops. And it's pretty common. You see them, geothermal loops kind of separate typically from a building. They're off to the side, like you can see here in the closed loop borehole system. But we can actually put those loops in the foundation system we're already building. And we call these energy piles. So it's kind of a double use element. So here's an example of energy piles in Germany that we had seen a bigger uptake of energy piles in Europe. But what they're doing is saying, hey, we're already building a basement wall, right? So we can excavate down, and we're doing that with secant pile walls. We're already putting the concrete and rebar into the ground. Why don't we add the geothermal loop and put those geothermal loops into the ground, thereby providing heating and cooling to the building? It's something we were already building. So we did that. It was a little bit challenging technically because we had ground anchors going through the wall. But at the end of the day, it didn't add that much effort to the secant wall, basement wall design and construction. And now we're providing maybe 20 to 30% of the heating and cooling capacity for that building. So why aren't we using energy piles all the time? I think a lot of people just don't know about them, but it's also understanding how they would be used. So they're different than ground source heat pumps where you potentially could provide 100% of heating and cooling. This would be in the 20 to 40% range, and you just partner them with an air source heat pump. So it's a different kind of HVAC partnered system. And you do have to monitor the ground. In hot places, you could overheat the ground, cool places underheat it, so you can't provide the heat in the winter. And you do need to know a little bit more about soil than you would normally do for a standard project because of the heat capacity and heat exchange. So the barriers to implementation to me are that the geotechnical engineers designing the foundations that might know about energy piles aren't mechanical engineers, so they have no idea what the HVAC system is for the building. And on the other side, the mechanical engineers often have no idea that the foundation could provide heating and cooling capacity for them. So this is just a case of, if we want to be more efficient, if we want to have better resource use, even if the grid is greening, we probably should still use less energy overall, which this can do. This is just one example where if we collaborate across disciplines, we can achieve those goals for the future. Another fun thing to keep an eye on is carbon sequestration. So what can we do with that? This is a project that I worked on in my PhD, but a lot of you'll see kind of biocementation up and coming, and this is biocementation in the ground to improve the ground for the structure. And basically it's taking a water solution with urea, which is a fertilizer, calcium chloride, the urease enzyme and water, and injecting it into the ground. Once in the ground, the urease splits the urea and you can precipitate calcium chloride, calcium carbonate, which is essentially limestone, into the ground, cementing the soil particles together. What's fun about this, here's the calcium carbonate you can see under the SEM, binding the soil particles together. And here's actually my research showing how we do that in this beach sand. What's fun about this in the future is right now urea is derived from natural gas, so that's not great. But if we can instead get that carbon dioxide from another place, like direct air capture or from an industrial waste product, then when we take that CO2 and we capture it as calcium carbonate in the ground, we're now doing carbon sequestration and improving the ground. So instead of dumping carbon, in traditional carbon sequestration, putting it deep into the ground as a storage solution, now we can actually use it to precipitate minerals that provide a function for the building industry. So that would be mineralization. Another concept that's up and coming out of the Bay Area is Blue Planet systems. So they're actually synthesizing limestone aggregate in the lab with taking CO2 from industrial emissions, combining it with calcium, growing aggregate, looks like this. And you can put it in the ground and basically, or put it into a concrete mix and basically make a project carbon negative. So these are really cool things. Who knows if either of these things are actually going to really take off? But the point is that things are changing and there's so much possibility. Right now, I think the building industry and construction industry are kind of thought of as a net negative for the environment, when ultimately we might be thought of as a net positive. So my conclusions on carbon are we can reduce carbon on every project. It helps if we can calculate the carbon because then that leads to reducing and we know what we're doing. A lot of our carbon reduction efforts, particularly at the start, are going to save cost and or schedule, right? Designing better, putting less into our buildings is going to be good. But, and I know from a code perspective, also being safe. But there are challenges, right? Collecting to support innovation and new ways of thinking so that we can put that into a code. We can make it acceptable. What do we need to do? We need to be clear on the path there. It can be hard from a construction perspective to change designs late in the game. We may have the best ideas, but if we're too late, you know, the project is too far down the road and we can't implement them. So we need to get in early and be thinking with that carbon lens earlier. Also, sourcing materials can be hard. In my community, I know we need to work together on this effort, but also we have to engage other disciplines. And that's really going to be the future, right? How much better can each discipline do on their own is going to be limited compared to if we come together. And lastly, I think geotechnical engineering, but also the building industry can ultimately have a net positive. So I'm actually just going to stop there because I know we're close on time and I want to leave a couple minutes for questions. But yeah, that's mostly what I have. So I'll stop sharing and open it up.
Thanks very much, Kimberly. Very informative, and I really enjoy your passion. It's obviously, even though you've done a PhD in it, it's still a passion. So thank you so much for that. Do I have any questions from those assembled? David, you're on mute.
I put it off so I wouldn't disturb matters, but you know, very interested in the presentation, very impressed. What we find in the UK is that a lot of the clients don't understand the need to think in terms of resource and, you know, the long-term performance. We're working hard at it, and some of the suggestions you've got there are ringing very true. So thank you.
Thanks.
Any other questions of Kimberly? Judy, go ahead.
Thank you. Thanks, Kimberly. I just returned from Baku, and so this is sort of a continuation of the conversation. Thank you. I just wanted to add, for the benefit of everyone on the call, that ICC has two resources that we're working on in this vein. One of them is a new standard with ASHRAE, standard 240 for the measurement and verification of embodied carbon. That is probably going to go out for public comment in January or in first quarter. And the second item is a recently released report in a project that we're working on with Standards Australia, actually, on a common data model for carbon measurement in the building sector. And it's fairly technical, but there's a recording of a session that we did announcing it last Saturday or 2 Saturdays ago in Baku. And I can share those resources for if people are interested in sort of getting further into this discussion about carbon and mitigation.
That's great. Yeah, and
Thanks,
I'll look
Judy.
for that ASHRAE.
Yeah. And there was a question from Gwen online. Is the risk assessment in that beginning of the presentation recognised by FEMA and or the Paris Accord?
I don't know how to answer that, so no. I'll take you back on that one.
No worries. Thank you so much. No other Gwen, go ahead, mate.
Yeah, no, I was just kind of curious. So thanks for the presentation there. I do meet with the Builders Association quite often. They do a quarterly meeting that I attend, and there's two recurring theme that I get the feedback I get back from them. And so I work for the city of Tacoma as a regulatory agency. Their number one priority is time, right? So how fast can we get it out? How fast can they get it into us? And so the question is, from a design standpoint, a lot of the times the engineers will do as simple of a design as quickly as possible for these developers. If with the presentation that you provided with these carbon footprint savings, all the calculations, how much time is either added or decreased overall? I mean, that's going to be a question that we're going to get, right? And then part two of that is the second thing that they always pound in our head, especially the smaller developers, is cost. You know, how much cost overall by, you know, you got to include the geotech, you got to include the mechanical engineer, that time and cost to hire these guys and the time that for them to design and do the calculation, how much of that is added or removed to the overall cost of the project. So those are the things that we as agencies would need to be able to provide them in order to, you know, fall on board with this.
Mhm.
Hopefully that makes sense.
Yeah, no, of course, I work for a construction company, so we hear this all the time as well, and particularly we're often a subcontractor. So what can we do on cost and time? And I think what ends up happening is if you can bring the right people in at the beginning, you're going to save time and cost. It's when they think of this stuff so late that the changes and trying to redesign is going to be expensive, and it's going to take, you know, more time as well. Sometimes we can still get in there because the cost savings and that value engineering, thinking differently and using a different lens, will be significant enough to do that. But I think what it is going to be is coming in early. Like we all know that cost and impact, you know, it is all early. And if we say we want to do this also with the carbon lens, I think then we can get there with these groups. But you're right, if you're going to scramble at the end, which I see we're doing projects in New York City for the new Manhattan Tunnel right now. We're doing the Hudson River Ground Stabilization. At the end of submitting everything, they say we want a 30% reduction in carbon. Well, now you're going to pay. If we had thought that from the very beginning, maybe we would have had more time to set up getting those materials from the right supplier and having it on time to meet the schedule. Now we're going to pay a premium for that. So I think it's just the timing of the project and getting that lens, that carbon lens early, and then you will recognize the savings. But we see things like, for example, my own company tracking fuel, because we report on our scope 1 emissions for fuel use. A lot of people weren't really paying attention to fuel. I know it sounds silly, but fuel costs compared to concrete costs are small. But because we're having to track it from a carbon perspective, now they're like, oh, we should have really been paying attention to that because it does cost money. So bringing that as another lens and another reason to think about the materials we're using, think about maybe how we're using excessive materials and wasting a lot and cutting that back. But again, the earlier the better. I think is how you're going to have to deal with that.
Okay, thank you. Seeing nothing else, again, thank you so much for that, Kimberly. That was very insightful, and I hope we can get a copy of those slides to circulate to those online. That was a great presentation, so thank you. And that does bring us to the end of our meeting. I know we're slightly over time by 6 minutes, but that's fine. Considering we didn't have a quorum to start with, that was we've spread it out quite well. So thank you again. And on that note, I'd like to wish everyone compliments of the season as we come into that crazy time. I know our American friends are heading into Thanksgiving, and we will won't see each other again until the new year. So compliments of the season to everyone. And we will circulate the meeting time for our February meeting once that's been firmed up. And Ahmad has his next speaker, and I hope it's of the same quality as the one we've just had. So thank you, everybody. Oh, Manjeet, go ahead, mate.